Okay. Hi, everyone. My name is Pablo. I am a support engineer in the support team in Percona. Here at my side is Agustin, my colleague. And today we will be presenting parametrization hints for intensive workloads. The main idea here is to share with you some information related to the statistics we have from our own shop related to performance tuning and those tickets related to the parametrization. And basically, we want to share some ideas that could give you a clue that not everything is the shared buffers, right? There are other parameters that can improve the performance. The main idea is to cover some incident statistics from the last year, the top candidates, parameters, share some monitoring and data collecting or data gathering tools and tuning tools available. In this slide, we have the top parameters we found on the last year in the Percona cases we were working on. So at the right, you will see the incidence of the parameters in the case we were working on. You need to consider that the number of the incidents is not related only to the performance cases, but all the cases we worked on. So if we consider only the performance tickets, the numbers are higher than we can see here.
So now we will discuss the top candidates, configuration variables, and why do we say candidate? Isn't there like a list that we always apply to all customers? No, as you already know, it depends on your workload, right? So the configuration variables you need to tune will highly depend on the kind of workload you have, right? So how can we assess which candidates we need to pick first, that we will have most gains? Well, in that case, of course, we will need to have some monitoring tool available and data gathering tools available to get that information from. And this is why we are adding at the end these last sections on how we can get this data from our servers and what helper tools we have to aid on this. And then, how can we measure and quantify the improvements? We need, again, data gathering tools and know what metrics to look for in each of the subsystems that we are interested in. So let's begin. Now we are going to discuss all these configuration variables that we had listed in the previous slide, and we will briefly discuss about what they do and how we can tune them. So the first one, we are using the same. If you get the PostgreSQL, the Postgres log, it will be divided in sections. We are using that same structure here, and the first one we find is on connections and authentication. And the one, of course, that we have most seen affecting your workload is max connections. We typically suggest using 10 times the amount of vCPUs you have available. This is of course just a general guidance on it. Yeah, that's a very good question. This is all the connected clients. So if you're idle, you still count against this. or I guess the suggestion of using 10 times more. So in Postgres, you typically don't want to have many connections in idle, because as you know, in Postgres, the connection is a process in of itself. So it's kind of heavy versus other databases like MySQL that uses threads for them, right? So you typically, yep. No. If it's idle, it won't. If it's idle in transaction, it can. Those like idle in transaction, you should aim to not have, right? Or if you have, it's just a very small spike between for the lag between the application server and the database. But you typically don't want to see like 50 connections idle in transaction. Yes. The best thing would be go to the application team and tell them this is not how you should use the connection. But if they are not cooperative, you can just set the timeout. Yeah. But yeah, that was a very good question. Max connections is global. Idle in transaction, active, all of them. If you need to exceed that number, let's say 10 times the virtual CPUs, what we generally suggest is then that's the time when you need to use a pooler, right? So put a pooler before the database, just connect from the application to the pooler direct, like PG pool or any other you want. Yeah, no, it's fine. Yeah, that should work. Yeah. So now we will discuss resource usage, except the write-ahead log section, which is the next one. So work mem is the amount of available memory that each connection will have for basically sorting operations. If you exceed the work mem, the temp table goes to disk, right? So there is a balance here in the amount of memory you allow a connection a client to use, and the time or the size before you need to go to disk, which is of course more expensive. You typically don't want this to be large, because this will go against all the connections. So with links to what we were seeing before, if you have a high max connections and a high workman, potentially, like worst case scenario can be that if all connections try to use the most workmen they can, you could get into an OOM kind of situation when you deplete the server out of memory, right? So again, there is a balance. You can, if you need to increase this, you can do it on a per session basis. So that's a far more safe approach, right? If you have the application team know which which code paths will need this increased, and they can do the set themselves. And then the shared buffers. This is what Pablo was referring, like the top one variable we always hear people talking about. So you already know about this probably. You can go up to 40% of the available memory. You can start by 20 and engage if you need more. There's not much more mystery with this. This is very well known already.
Yeah, yes, set that now and make that the when you get by some dot that's
Yeah, it's fine. No. You can do percent. That's 25 is fine. We've even suggest 40% in some cases, depending on. We will show you afterwards with PG Gather. There is a tool that we use. How you can check? Yeah, you use it. Nice. Yeah. Very smart guy, man. How we will tell you how you can gauge if you have memory pressure and you would try to consider increasing it. So then maintenance workmem, if you don't specify it, it will take the value that you use for workmem, but that's basically the available memory for the background process maintenance operations like vacuum. Then huge pages. If I mean, it's not like the holy grail of memory. Like it could be, it could improve performance or not, depending on your memory usage, right? If you have a lot of table,
Our basic manage.
yeah, yes, yes. Yeah, it depends on the page table usage. So if you need to map a lot of memory, you need to access the memory, you need to go to the page table. So if you see that is having a lot of hits, and if it starts to grow, Jobin has a blog post on it on percona.com/blog, and he discusses the use case in which you could benefit from using huge pages. So there is a case in which you could benefit from setting it, but it will depend on each one, right? And then the background writer LRU max pages. This, if you need to increase this, I would say you should first start by increasing the max wall size and checkpoint timeout, because most likely the background writer is doing work because your wall size is not enough, or you're doing a lot of checkpoint. Then the background writer delay, it will tell how fast it will run. And then the auto vacuum workman, it's the same as the workman, but for auto vacuum. Wall was you, right?
Okay, the next section is the write ahead log. So, okay, we have the max wall size. There is, give me a second.
So we're good. So the base.
Yeah?
I think what's this?
Shit. No. Sorry, this was my section. So we have the wall section. This is also very important, and one of the great, thanks. Does it? Oh, it's working now. Okay, thank you. So this is one of the configurations that I've seen impact most the database workload, right? Checkpoint timeout and max wall size, they are like, I don't know, 80% of the performance issues we have. They need to be increased. So what do they do? Max wall, they are very linked to each other in the sense that if you have a checkpoint timeout that is, let's say, 30 minutes, by default it's 5 minutes, which is very low. We always suggest using 15 or 30 minutes. This will depend on your recoverability TLO, I think it is. So the time you need after the server crashes, it will need to replay whatever walls it had to replay, right? So if the checkpoint timeout is too large, what you will have is you have a debt for the next time you restart, right? But on the other side, if you extend the checkpoint timeout, you avoid doing the sync to disk, the writes to disk, right, to the table. So so there is a benefit in increasing it, but past 30 minutes, 1 hour, there is also a risk in increasing it further. So I think that to begin with, 30 minutes, 15 is fine. And then what probably will be your limiting factor after you increase the checkpoint timeout is going to be the max wall size. Because the max wall size also determines checkpoints. So if you have writes that amount to the max wall size, there is going to be a checkpoint there. right? So by default, I think it's 1 gig. So if you have a write-intensive workload, you are probably writing more than 1 gig per 30 minutes, most likely. So that will mean that the limiting factor there will be the max wall size, and you will need to improve it. We will show you again how to check if this is an issue in your server. Basically, you can add the log checkpoints and check the logs. Or pggather again tells you how many forced checkpoints. The notion between the forced checkpoint is that your max wall size is not enough for your write workload. And then we have mean wall size, which is not as
max wall size. The DBS are cutting of usually set for CD, but
4. Yeah, it can be. Yeah, 50 is okay. Yeah, I mean, there's nothing but if you have disk space, I mean, I don't see any reason why not. Again, you will want to set it as high as possible as you possibly can, because this is one of the variables that most affect performance, in my opinion. What I've seen making the most change is max wall size. Even when I was preparing another talk for extending PMM, Percona monitoring, and one of the extensions I did was checking wall size, checking the writes per checkpoint time. So what I did is I lowered max wall size, and then I put an intensive write workload. That was giving, let's say, 10 gigs of writes per 5 minutes. After I increased the max wall size to a very high number, like higher than my writes per checkpoint, my workload even increased. So I was writing more per checkpoint per 5 minutes, right? So this will, if you increase it, you may need to increase it again more, but that just means that you have just improved the performance of the server by a lot. And then mean wall size is really not as impacting on performance, but the mean wall size, basically what it does is it will keep that amount of walls to be reused by the new wall files that are going to be created after. And then checkpoint completion target, in the latest versions it's already 0.9. It's a very good default already. Probably no need to tune it. But what this does is when you have a checkpoint, Postgres tries to split the work in 0.9 is, let's say, 90% of the checkpoint timeout. So if your checkpoint timeout is 10 minutes, Postgres will try to do all of the writes in the 9 minutes. So it will separate them. So it doesn't have to do one big write at once. Again, defaults in latest versions are fine, but you may want to check it just to double check. Okay, now.
Okay, the next section is about the replication. This section is linked with the previous one because the parameters we want to cover here are the wall keep segments or the wall keep size, depending on the Postgres version you are running. Those parameters are related to the amount of walls we will hold on the PC wall for the replica. This number needs to be set something in the middle between the min and the max wall size. And the main difference between them is that in the older versions, the wall keep segments was related to a number of walls. And if you want to decide the proper size for that, you need to do some maths, which are related to the number of segments and the size of the segments, which by default is 16 megabytes. In the newer versions, it was modified so you can specify the size of the walls you want to retain for replication in a straightforward way. And the important thing related to this parametrization is that if we are able to hold the wall files for replication, we ensure that the replica will be always streaming, even if it lags behind for some time. Also, because if the replica lags behind for so long and we do not hold the necessary walls, the replica will need to switch to wall apply, which means that the replica will switch to recovery mode, right? So we are not able to perform queries during that time. Then we have a section related to query tuning. In that section, the parameters we see most frequently are the random page cost. The random page cost is related to the disk performance. Depending if the servers we are running on are spin disks or SSD disk, is the number we need to set here. The random page cost relates to the disk speed. So, for example, for 15K RPMs, the seek time could be something between 3 and 5 or 6 milliseconds, right? It's the performance of the disk. So the standard value, the default value for the random page cost is 4, which is accurate for the spin disks because it's like a legacy default. But nowadays, most of the companies are moving to SSDs. That means that the latency is too low. There is almost no difference between a random page cost and a sequential page cost. So we can reduce the random page cost very close to the sequential ones, right? For the sequential page cost is the default is 1. So if we are running with SSD disk, we can move the random page cost to something very close like 1.1, and then the optimizer will be prone to produce execution plans based on index scans. Then we have the default statistics target. The default statistic target provides some clues to the optimizer, and it's related to the amount of data that will be scanned and analyzed or collected during the analyze executions, right? So the higher is the default statistic target, the more accurate data, the more data the analyst will be scanning, and then the more accurate the data will be. If we have a table which is with where the data set is very homogeneous, then the default will be okay. But if the data set is very heterogeneous, then it could be possible that the default statistics value is not accurate, or it does not get accurate metrics, accurate statistics, and it could mislead the optimizer. So for those cases where the data set is not homogeneous, we need to increase the default statistics, which provides better statistics, but at the same time, that has some cost because the analyst will need to screen more pages, read more pages, process more information, and then it has some cost involved. And finally, the other parameter we see in this section is the effective cache size. The effective cache size does not allocate or pre-allocate any memory. It's just an insight for the optimizer. And as you know, Postgres relies on double buffering, so we have all that pages that we hold on the shared buffer, but we also have many pages that are held on the file system cache, so we can avoid going to the disk. The effective cache size is the amount of size that we have in file system cache, right? So the larger is this number, the optimizer will try to will think that we have more information in the file system cache. So the larger this number, the more prone to produce index scan execution plans. Okay. After that, we have the auto vacuum section, which is highly discussed in so many cases. We need to understand that all the parameters related to the auto vacuum are not per auto vacuum, are related to the auto vacuum, right? So we have the auto vacuum cost limit. The cost is an effort measure. It means that it's not something like a number of IOs, it's not a number of cycles on CPU and so on. It's a measure of effort in the database. And once the database reaches, once the auto vacuum execution reached the cost limit, then it will stop for a while until it retries. So that means that auto vacuum runs in small batches. The higher the cost, the most aggressive will be the auto vacuum. So here is a combination between the auto vacuum and your workload. If we don't want to be too invasive on the workload, we need to set the cost limit in lower values. And if the workload or if the workload does not consume much resources, we can set this value in higher numbers, which results in much faster vacuum executions. Then we have the auto vacuum max workers. The workers are basically the number of auto vacuum executions we can concurrently run, but we need to consider that all other parameters are related to the max workers, because the cost limit is not per execution, is related to the auto vacuum itself. So if we have 4 workers, it means that all the 4 workers that are concurrently running can reach the cost limit at the same time, and all of them need to stop for a while.
Wow. So this vacuum cost limit is far about the individual what?
That's correct. And one of the common mistakes is that people tend to think that increasing the number of workers, it's like running processes in parallel, and that will speed up the process, the auto vacuum. But the result could be that, but it could be the opposite, because if we increase the number of workers to, let's say, 100 or 16, it could be possible that we can vacuum 16 tables at the same time, but the speed for all of them will be lower than if we set a lower number of max workers, right? The lower the numbers, the more power for each execution. And then we have the cost delay. The cost delay is basically the delay between vacuum operations. If we have 4 vacuums, once a vacuum stops, we have some time until another auto vacuum can be triggered. Okay, that avoids that we triggers too many vacuums too frequently. Okay, and the uptime. The uptime is we mentioned that the cost limit is for all the workers, and it's a measure that allows the vacuum to process the table in batches. Every time we reach the cost limit, we stop for a while, and that time is decided by the nap time. The nap time decides how long you will vacuum will need to wait until the next batch. The next section is the client connections. Here we have the statement timeout. The nap time is related to the time vacuum will go to sleep in the same execution. So, for example, you have a table of 100 megs. You are not scanning and cleaning up that table all in a shoot. It will be done in a couple of batches. So it means that if you need to do that in 1,000 batches, the nap time will be the time between batches. Okay, but the cost delay. Yeah. The cost delay is the delay between vacuum executions, not in the same execution, but in different executions. You cannot trigger so many vacuum executions in a single shoot. You need to wait for a bit.
And then it can start. For that, then is that something some vacuum model vacuum stating for some lots, but it is not the best.
No. Nap time is. I am right.
Vacuum.
Yeah. We are okay. Nap time is the time that vacuum will go to sleep between the batches. Okay? The next section is the client connections. Here we have 3 main parameters: the statement timeout, the log timeout, and the idling transaction timeout. The statement timeout is obviously how long a query can be executing. So we set a threshold, and if the query runs for longer than that, that query will be aborted. The log timeout is also the threshold for acquiring a log. If we are trying to perform something like an alter table, and we don't want to let the execution waiting for so long until the log is acquired, we can set the log timeout. So the log timeout is useful if you need to attempt to create an index or alter a table, and you don't want to let the the log to be if you want to avoid the log to be there waiting for so long. And the idling transaction session timeout is also related to what you previously asked. Those queries
about auto-web and processors.
It's not how long the log lasts, but how long it takes to be acquired. Okay? So let's suppose you have a very busy environment. You can trigger an alter table, and if that table is very busy, the alter table will never start because it cannot acquire the log, which is different that if the log is already acquired, it could last for longer than that. And the idling transaction session is it's very useful if you are not using a connection pooler and you are letting the application to create connections by itself. The reason of that is that sometimes the developers avoids to close the session, and if you have an idle transaction session, it could affect the auto vacuum because you are holding the edge of the table. So even if the auto vacuum runs, it cannot perform its job, or it will run, auto vacuum will complete, but will not be able to clean up those tables, those pages which are held by the idling transaction sessions. So the main idea is to avoid those sessions which are held for hours or days.
Okay. So this last section is not on improving performance, but on improving our observability on the performance, right? So we can take the good decisions on which variables we need to tune, right? So the ones that we want to suggest are log checkpoints, which will basically let us know if the checkpoints are being forced due to the wall size or if they are being activated because of the checkpoint timeout, which is what we want. Then we have log connections and disconnections, and then log temp files, right? So they do the obvious what they mean. And then another one that's very important is log auto vacuum mean duration. Typically, when we want to troubleshoot auto vacuum issues, we set it to 0. So all auto vacuum executions are logged. You can do this dynamically. And then log mean duration statement. This is for getting information on the queries, right? And after you log all of these, there is a very nice tool that you can use to get information out of it, which is PG Badger. Yeah.
The statement is never completed, but it is at 1 minute. So it is like running.
Yeah.
But it's not one computer. It's to the way.
That's a very good question. It doesn't. Yeah.
Yeah. If it was cancelled, for example,
The timeout.
out, it will not be reported.
Yeah. Yeah. So after you get all that information, you can use PG Badger to get a nice report on the log. And then the other two tools we wanted to mention are Percona monitoring and management and PG Gather. So PG Gather is a text-based tool that will query the Postgres server and will get information from the information views that we have, right? Like pgstat activity, replication, etc.
Did you get it? It's there. It's a tool.
We will show you now an example of PGGather. Pablo will show you. And then, yeah, Percona monitoring is great. We will show you an example here. It's great to have metrics from the database and the OS, the underlying OS. PMM? No. Yeah. Well, I mean, you can get kind of similar information, but they are. I wouldn't say they are the same. This was maybe we can now show you before going to the tuning tools. Where am I? There. So this is PMM. As you can see here, we have the PostgreSQL dashboard. There is a summary. We have information on connections, the tuples that were affected by the workload. We have logs, we have transactions, and at the bottom we have information on checkpoints and the buffers that are being used. So all of these can be used. For instance, here I can clearly tell that there was a lot of checkpointing going on. This is in 1 minute, right? So 11:27 and 11:28, and if these were from the checkpoint timeout, I would expect only to see one big peak here. The fact that we are having many small peaks means that we are checkpointing all of the time, and this is of course due to the max wall size not being enough. So there's a lot of information we can get from there, and this will continuously gather data in 5 seconds intervals. So there is a lot of data we have, historic. We can use it for root cause analysis or for assessing the performance at almost in real time. And then we have this. This is a PGGather report.
Yeah, the main difference between PGGather and PGBatcher is the source of the information. The PGBatcher will collect and process information retrieved from the Postgres log. So to get advantage of PGGather, you need to previously properly set what options do you want to log. The connections, checkpoints, the statements or auto vacuum or whatever. You need to previously set the login section of Postgres, and the PGGather is a tool which you can just download. You execute the data collection, and it connects to the database and retrieves the data from the database views, right? So it will also provide information related to the database size. It will provide information related to the schema, the tables, the indexes, if the indexes are being used or not. Also, it will retrieve all the parametrization. And if we have something like pgstat statements also installed, it will retrieve information on the ongoing session. Finally, it will show 2 important sections, which are the findings. The findings will let you know if the database suffered a crash, or if we have tables running without auto vacuum, tables which are not being analyzed, if we have too many temporary segments being created, and so on. It's like a summary. The findings is like a summary of the findings on the database side. And we have the background and checkpointer section, which let us know.
Some of the other.
Okay. So, for example, depending on the workload and the configurations, it will let us know if we are suffering for the checkpoints, as Agustin mentioned. It could be related to the max wall size. If we stay on the section, it will provide some insights on what we need to tune. It will provide information about if we are checkpointing too frequently, if we are, in this case, doing how many is the relationship between the clean by the background writer and the clean by backends. Usually the higher values on the clean by backends means that the backend processes needs to do some of the job of the background writer. The background writer is not able to do all the job on his own. So the backends needs to fit some pages in memory, and they need to flash some of the information from the memory. And it will also show some information related to the holds on the back writer. So, as mentioned, you can stay on the offenders for a bit, and it will let you know what are the main parameters we can tweak to tackle that.
Unfortunately, we cannot take we started with the other which means like parts of the morning, some issue would happen from maybe in 10 a.m. Then after that system was sick, Sure, BDM do all that, there was some issue there. Well,
you are totally right.
Yeah, it is that activity or not. You need to execute phishing other at the time you are running with a project there. Yeah.
Okay, and finally, and we are a bit over, so we will do this very fast. There are also tuning tools that we can use, but there is a very big caveat here that, I mean, it's nice to have because they will give suggestions on what you may want to tune, but some projects have been abandoned or not maintained for a long time, so they are outdated, which means that we don't have the current versions into consideration. And then there are some that are very basic, like pgtune. It's nice to use, but it's really basic, and it will the heuristics it uses are not complex, let's say. Then the first one, PG Autotune, is one we did with the development team and the services team on a hackathon on Percona. We had 1 month ago, I think it was, we did a hackathon. We did 3 teams, and the idea was to improve the defaults. And this is the tool we came up with. So if you want to check it, it's really cool, and it can give you good suggestions, at least from where to start with. And yeah, with that, unless there are any other questions, this is the end. Yeah. Thank you very much.